All right, looks like we're time. So thanks everyone for, we happy few. I appreciate you sticking around till the end. You guys really want to get your money's worth out of this conference, and you're the people I want to talk to anyway. I know I'm the last line of defense between many of you and a cocktail, so I promise to make this fun, and I promise you'll get something out of it. So if you saw the title change. I've done this session a few times, and this is the name I do it under now. The name I registered it under was this. I'm not baiting and switching you. It's just a better title, I think. But what we're going to talk about is where do we do data quality in a data lake or a lakehouse or a warehouse? I think this is fully applicable to any kind of data platform. And this is the name I've been going under lately. And we'll talk about what I mean by enrichment as we move through. One time and one time only, if you want to follow me, there it is. I don't see any cameras up. Oh, it's fine. It's fine. You can find me. There you go. We have a few takers. No prizes. You're not entering to win a gift card or anything. I'm going to talk a few minutes about my company, Qualitics. Just a few minutes, it's the price of admission, and then we'll move on to the good stuff you're interested in. We like to say we're the data quality operating system, and we do all of these things. Automated profiling, so stop writing manual tests. We'll build them for you and keep them up to date as your data changes. Use those to detect anomalies, and then we help you resolve those anomalies. It's not enough to just observe your data. You've got to take action against bad data. And we do that with workflow, APIs, and all sorts of actions that you can enable. If any of that sounds interesting, please grab me afterwards, or if you follow me and you want to talk about it, and all runs completely in any of the 3 clouds, so it's Kubernetes-based. That's been a buzzword this week, hasn't it? 100% Kubernetes Spark on Kubernetes, so it's something that many of you are familiar with. And we deploy it either in your cloud, in a single tenant cloud, similar to Databricks, or Azure Databricks, really, or however you really want to deploy it. With Kubernetes, we can deploy it any way we want. Tell us the region in the cloud, and we'll deploy it. And on to the good stuff. I usually put this slide at the beginning of my talks because I want to talk about my purpose for doing this talk. And one of the burdens in trying to talk about where to do data quality is there isn't a lot of agreement about what exists in these different zones. My gold may be your silver may be someone else's bronze, right? So without that sort of universal agreement, it's hard to start talking about what kind of data quality concerns we do in these different zones. Don't worry. I'm going to tell you exactly what you should do in these different zones. I'm going to tell you what bronze is for, I'm going to tell you what silver is for, and I'm going to tell you what gold is for. Now, just because I tell you this doesn't mean you're going to go change it. So what I want you to do is focus on what I'm storing where. Think about where you store that. And this is where the particular data quality concerns I'm going to talk about belong. Does that make sense? Is that a deal? So you don't have to run out and make your bronze look just like mine, but I am going to tell you what I think your bronze should look like, and I am going to tell you what I think your silver should look like, and on, okay? I don't think this is a relevant distinction for this talk, right? So I know what a lakehouse is. It's a data lake with a bunch of new capabilities in it, right? Replacing that need to build a warehouse from a lake, on, right? 100% on board with that message, and I believe in it. I don't think that distinction's important for a data quality discussion because I think the data quality stuff should be in the lake piece of your lakehouse, right? So as long as you're building a lake, whether you're also building a lakehouse or a warehouse downstream from it, I don't think it matters, okay? So let's focus on the data lake zones for this talk and not worry too much about semantic distinctions between other platforms. So a little bit of a marketing slide here, but there's a reason for it. So these are the 8 categories by which we as a data quality company want you to consider your data, the quality of your data. So normally this is sort of a marketing slide that we have in some of our sales pitches. But what I'm going to do is, as we talk about the different zones, and I tell you exactly what your data should look like in those zones, I'm going to apply a few of these categories in that zone and talk about why it's important in that spot, okay? So that is the reason for this slightly, and this is going to be like a lot of data qualitative assessments of data. There's nothing new here. I mean, we believe in it. It's our North Star, but we didn't invent this. We just curated it, so to speak. Remediation is the idea that when you detect an anomaly, it's not enough to just have it in a UI, okay? We need to make that anomaly available to data engineers and scientists, okay? And there's lots of ways to do that. You can, I'm going to talk about how, I'm not going to demo it because the 35 minutes really doesn't provide enough time. But I'm going to give you a pro tip on how you can do that with live tables, how you can detect anomalies and enrich. And then also, of course, you could just buy our product. So, so your choice. So here's the pro tip. So currently in Delta Live tables, if you write an expectation, there's no way to populate, there's no way for you to quarantine bad data or anomalies, right? So if you were to write an expectation, that blocks rows from going through into a table. So what you can do is you can write another Delta Live table with the inverse of your expectation, and that will put all of your anomalies in a live table. Does that make sense? Right? So if you say must be in this list of values, must not be in this list of values, suddenly you've got an enrichment table. Make sense? So that gives you the ability to then take those records and take them to resolution. So as I go through these different zones, I'm going to talk about some possible remediations you can do, assuming that you have enrichment tables, okay? You have the detected anomalies available to you. We call them anomalies because they may or may not be bad data, but they're still important because mathematically they're anomalies, right? A data engineer might be more interested in whether the data is correct. A data scientist is more interested in whether it's useful or predictive, right? So they have completely different data quality concerns. So yeah, as I said, I'm going to map those different data quality concerns as we move through the platform. So you've probably seen lots and lots of different slides like this. This is my take on it, built from the ground up. And we're pretty familiar with the raw area. This is where data lands, right? And notice that raw is separate than bronze. Bronze is grayed out, but you're going to see it. The idea for raw is that this is not your all-time historical collection of raw data. That's bronze, okay? This is your temporary workspace. So if you need buckets, if you need to land data from Fivetran, if you need to ingest files, if you need to whatever, that goes in raw. And that's not counted on to be, it's not a zone that you really expose. Neither one of these are zones that are exposed to workloads, okay? And then the work area is just, whatever you need for data ops, cloning, sharing, sandboxing. Really, that's what belongs in the work area. These are not that interesting, right? You can do this any number of ways. This is where the rubber starts to hit the road, okay? So I am going to go through each of these zone by zone, but I'm going to give you a little bit of a high level right now. And that high level is that bronze, this is where we append only data for all time, okay? So we want all the data, all the changes, everything that's happened to it over time, okay? And the goal there is we're trying to represent the source system. Data existed in a source somewhere. That source might be an edge device that sent a payload. I still think of that as the source, okay? What is in the source? We need to track that somewhere. We are not fixing bad data yet in bronze unless we got some sort of a bad feed. where we don't have data as it was represented in the source system. At this point, we're laying down a foundation. We're decoupling our needs of interacting with the source system, right? We're landing all that, and we're making this idempotent all the way through to the end. I should be able to restate data as many times in as many zones as I want, as often as I want, downstream, okay? Moving into silver, silver is where we start trying to represent what happened in the world, not what happened in the source system, okay? These are business entities. Customer underscore demographic and customer underscore address and customer underscore type don't exist in the world. Customers exist in the world. So we want to build business entities in silver that correct data and make sure it represents what actually happened in the world. So an incorrect office code is corrected at this point, okay? Even though it's in the source system, it's bogus and incorrect, this is where we start to correct those things, okay? Moving into gold, gold is where we start to add our secret sauce. This is where we add our opinion. We have not injected any opinion up to this point. We have just simply tried to tell you what happened. Events exist in the world. We want to model those events in our silver layer. Gold is where we start to say, this is what is competitive about our data, and this is what tells a story about our organization. This is how we attribute customers across multiple platforms. This is where we calculate percentages that are meaningful and binning customers and talking about who is our good customers, who are our bad customers. This is where we start to add those calculations. So now, obviously, in gold, we need data quality concerns that help us with that, okay? And then diamond is sort of a grab bag, okay? So for some people, diamond, and I fly Delta, so that's why I chose diamond. If you fly Delta, then you probably, that's why I didn't choose platinum, because platinum's kind of played. Diamond is where it's at. I know some people talk about diamond only in feature stores and ML models, and I agree, those go into diamond. But we also now that we can store data as many times, as much as we want. We're not constrained by compute, right? We're not constrained by storage. So we can build and state our data as many different ways as we want. Used to, we would stop at gold. But now, if you've got a Tableau workbook and you say, I just want one big wide table, and I don't want facts and dimensions and all of that, just build me a wide table, we'll build that for you. This is where you meet the customer where they are. I want the data to look like this, or I need it very specifically like X, Y, or Z so that I can put an API on top of it and version it over time, okay? So this is where products exist. This is where publications exist, and feature stores and ML models. So this is where you start to really send data out to consumers. It's not just about dashboards anymore. It's about these little devices, right? And we have an expectation when we, in our consumer world, the data is readily available and absolutely correct and in the format that we want it. And we should start doing that exact same thing for the business or for the organization. I'll take questions anytime, by the way, so just raise your hand. Does this make sense? Yep. Go for it. Yep. You'd build that in gold. And by the way, well, this is one of the things, so you can see my gray hair. I've been through the initial data warehouse on-prem explosion, the big data revolution, the cloud evolution. I've been through all that. We built similar stuff to this on-prem. Not exactly, but we never exposed, we didn't build diamond, we built gold. We did a lot of staging layers and other things. We kind of built some of this stuff. We just never exposed anything but gold. The point in this is that all of these zones are fit for consumption for different workloads, right? So your question is it in gold or diamond? We will build exactly what you're talking about in gold. So facts, dimensions, if you're into Data Vault, if you're into corporate information factory, whatever is the modeling technique that you believe in, that goes in gold, okay? Now, we start to segment that out and make it easier to use. So gold is what we build as an organization. Diamond is what your user says, I have this requirement, I want the data to look like this, I want it refreshed this often, here are my requirements for how I want the data. The people that build Diamond typically sit with the business. That's another thing to keep in mind. I don't often, well, if you're a large IT organization that's been around for a long time, Diamond is probably still being built by something centralized. But what I'm starting to see in a lot of newer companies and rethought data teams, Diamond often is sitting, the people that build Diamond is sitting with the business. And they understand the gold layer, they understand what's in there, they have some input into how gold is built, but he or she is building that Diamond layer fit for purpose for whatever product they're delivering, whatever data product they're delivering. So I don't know if any of you are software developers. We're all developers, right? So we're just data developers. If you've ever worked in the software development, building front ends, I'll say, not real software. What we build is real software, but you know what I'm saying. A software application, right? Then you've probably seen the testing pyramid, okay, which is what I'm describing here. And it's the idea that the best bang for your buck is in the unit tests, okay? Because there's a single dollar sign. That's not even a dollar sign, that's a cent, right? So the idea is that if you can catch the error in the unit test, it's way more cheaper to fix because it's reverberated all the way downstream, okay? So I want you to keep that in mind as we go through these zones. I see way too many people do data quality only in gold. I also see people who try to do all data quality in bronze, okay? There are different concerns in different zones, and we need to recognize what the zone is for before we talk about what kind of data quality we're going to do at it. However, catch it as soon as you can. That's really the point here, okay? And we'll talk about it as we go through. So let's jump into bronze here. As a refresher from 5 minutes ago, this is where we try to reflect the state of our source system, okay? So data coming in, as it exists in the source system that may not be right, stays wrong in this layer. Because wrong is just from a different point of view, right? It is correct from one point of view. It's incorrect from another point of view. So, and bronze is a valid use case for consumers. Go for it.
Use the word changing state. You're not doing anything change tracking in bronze. It's just a page reflection.
So, again, I'm giving you some opinion here, but I believe bronze should be append only. All changes. You need to flag it as deleted, right? So again, I don't see this all the time, but think about this for a minute. I'm going to give you a quick example. I've only got 15 minutes. I'm going to give you a quick example. I had an online university. We were building a platform. And they said, there's no reason for us to store changes to the UI over time. Okay? So they had that data. This component moved up here. This lesson now has widget ABC in it. And this became some of the most valuable data for customer journey, or student journey, I should say, as they're able to track. They're able to score the value of these UI changes. So the point I'm making is that the source, it's not enough to just replicate the source system here, because often the kinds of analytics that we want to build in silver and gold require us to say, I need to know not just a product only sold at $1, but there were 5 price changes during the day before it got to $1. If all I do is track the dollar sell, I don't understand the momentum that led to that sell. So I would say, yes, if you can, because storage is cheap, right? Storage is cheap. And it gives us the ability to do item potence be item potent that just simply means, if you don't know what that means I can run something as many times as I want. The end result's the same. We never did that in the old days. If you ran the load again, you'd have all changed data, right? We want to be able to restate things all the way through these layers as often, or we want to stream, we want live tables. We want that kind of experience now, right? Make sense? It also decouples our lakehouse from requirements of going back to our source system. And I can tell you, I sound like a boomer, right? But we used to have to reload the warehouse from source all the time in the old days. And it was painful. But we didn't have enough storage that we didn't have to do that, right? Now we have enough storage. So do yourself a favor. So these are the Qualitics 8, or we'll just say the data quality categories that we're concerned with here. So we're concerned with volumetrics. Does the data batch size look like the data batch size I usually get this time of day, this time of month, this time of year, on this day of the week, with slight trending numbers or down, up or down numbers, okay? You want that, because this is telling you that the data you're getting is probably not reflective of the source system. It's flawed, right? Okay, does that make sense? You got a bad feed. You had a network outage. You only got half the load. All these sorts of things, okay? Conformity. We want to make sure that the data sets that we're getting conform from one day to the next, right? This field is not a string today and a date tomorrow, okay? Because it needs to be one or the other. And also timeliness. This is the beachhead of our data, right? This is where the data is coming in. And any SLA we have in gold or diamond is going to be affected by the timeliness of the data arriving here. You have to measure that, track it, and trend it, and know when you're possibly going to risk an SLA downstream somewhere. Okay? Does that make sense? You guys kind of get how we're doing this. We're talking about the different categories. Now, this is where you want to. This is where you only want to fix bad data coming in because of feeds and all that sort of thing. We're going to wait till silver before we start trying to represent the real world. Does that make sense? Yep. And if you try to fix data coming in here, what happens when and you're fixing a bug that exists in the source system, what happens when they fix it? You've just introduced it, right? So don't try to do too much magic here, okay? Make sense? Awesome. So halt pipeline, I got ahead of myself here. Halt pipelines when batch sizes don't match. You might think about quarantining records that are bad and letting the rest flow through. Now, you know your data better than I do. Let's think of sales numbers. A sale comes in, and it's got an invalid product code. Well, we can hold that data back, quarantine it so that it can be resolved, right? But our sales numbers aren't going to be right. We're missing that sale. So I'm not prescribing here. I'm saying you know your data, okay? When we get to silver, we'll start to apply some fixes to make the data a little bit more conformed. Let's jump into silver, okay? So we represent the real world. So remember that if the source system is saying something that is not what happened in the world, we want to fix it here. But we're stopping short of starting to apply opinion, okay? You guys get what I mean by opinion? Where our calculation for how our magical algorithm for detecting churn or whatever it is we do, right? We don't start to add this here. This is a very valid use case. It's not a sexy term anymore, but we used to call it operational reporting, right? And how many users do you have that say, don't give me facts, don't give me dimensions, I just want to know what happened. I just want to know the source system. That's a good bronze use case, but that's a complicated model. I wish I don't have the institutional knowledge to know how to go join all these tables together to get the result. That's silver, okay? And that's designed to be subscribed to by certain workloads, okay? Everything that an end user uses doesn't have to be in gold, okay? Yep, that makes sense. So you're helping the people who aren't domain experts of the data, right? So a marketing person looking at marketing data in bronze, they can query that all day long, right? A logistics person has no idea how to join those tables. So silver is designed to stop people from slacking and asking, how do I join these tables? Okay, it's joined, and it's corrected. So this is where we will look for accuracy. So this is the data quality category that talks about the real world. Okay, is the data accurate? And by accurate, we mean it represents what actually happened. Okay, completeness. Again, some of these are going to overlap. We're going to see them. Make sure that the fields that we expect to be populated are populated, not null values. And coverage. So we're starting to think about, are we getting all the data from all the source systems? And are we conformed across those source systems? Make sense? Yep. If we take a look at a remediation, this is where we would start to say, fix some codes, right? We have a distinct list of values. We know that hire date should always be in the past. We know margin should always be less than cost of goods sold, or no, a sale price, right? These are some of the rules that we start to expect, that we know these things should exist in a certain way, regardless of what the source system tells us, right? Awesome. If you haven't heard of the Levenstein, I think I say that right, distance formula, raise your hand if you've heard of that. Yeah, we got some real nerds in here. Awesome. This is a way for you to say fuzzy matching, right? So it's basically a formula that says a string is, what's the distance between two strings and the number of characters it takes for me to, the number of changes I would have to make for those strings to be identical. That's the distance side. So what you can do is with a certain tolerance or distance that you're willing to live with, you can go do a lookup and find the best match, okay? And if that match doesn't exist, if that match exists within the tolerance that you're comfortable with, just replace that data. This is available in every kind of SQL there is, and absolutely available in Databricks. Silver makes sense. Moving on to gold. Any questions on silver? Awesome. Now we're starting to compete on analytics. Okay, anybody read that book? It's a little old now, but it's amazing, by Davenport, Competing on Analytics. But this is, I like to say, secret sauce. This is where the uniqueness of your organization starts to blossom. It's also where you start to combine data sets and see what happens, like an experiment in a lab, right? This is where you can say, I got this logistics data and this clicks data and weather data. Everybody wants to talk about weather data. And this weather data, can I get any insight out of that? This is where you start to look at those kinds of things. Driven by data scientists, usually. There's still some data science that's not ML related, right? You still have experiments that you want to test, and you don't have to deliver with a model, right? So sometimes this is driven by data scientists to go see if they can wring out a little value from some of the data sets, and then we combine them, okay? So if you think about, we also combine data that's not at the same grain. We're putting budgets, which might be at the quarter, with actuals, which are daily or down to the second. So we're starting to combine data, and our data quality concerns are about that. We've already fixed incorrect data that didn't represent the source system. We've already tried to explain what happened in the real world. There is no country called USF. Maybe there is, I don't know, right? So we've already fixed that. Don't wait until you're here to fix that, those kind of things. That's the biggest takeaway, I would say, okay? But don't try to do all data quality before we get here, because there is some data quality that only makes sense in this zone, okay? It's really, if I were to boil it down, It's data quality around bugs in your code, transformation code. That's really what it is, okay? We should, the join, it should have been an outer all along, but you never noticed that before because that data point never came in, right? So some examples here, single version of the truth across domains, and these are the data quality concerns we have. We're concerned with volumetrics here because it's an indicator of whether or not our aggregating or combining of data at different grains is reproducible and trending over time to the same numbers. Precision, obviously, we've seen that one before, and consistency, you've seen that one before. So a good example, let me see if I have that example. So you might quarantine when linear regression models, you can build linear regression models, and our Qualitics product does that, where you can see the relationship of columns over time, and that linear regression models puts the rails, and if something comes outside of those rails, then it's mathematically an anomaly. And what that helps you do is protect yourself in the code you write to build that secret sauce. A simple example is a column which is supposed to be a percentage is less than 100, or less than or equal to 100, okay? That's an example because if you muffed up that calculation, you might get 130%, okay? So start to put rails around these calculations, and it only makes sense in this zone because you're not adding opinion anywhere else. Make sense? Yep. Diamond. I'm going to go through this quickly because I'm running out of time. If anybody has any questions about this, please grab me afterwards. I think you understand what we mean by diamond. This is really anything downstream from gold, everything downstream from gold, right? Data built just perfectly for how the end user wants it. They don't want to do facts and dimensions. They don't understand what that means. I want the data like this. We'll build it for you like this. What happens in this layer is the reverse, not the reverse, but sort of the, reverse ETL is a hot topic, right? It's kind of the reverse ETL model, okay? We're starting to take that data that we spent all that time combining, elevating, aggregating, and we start to almost de-aggregate it and put it just for purpose. So a good example is segmenting data, pulling only certain rows out of the gold table because an end user is only interested in those certain rows. Diamond is going to have some calculations of their own as well, right? There's nothing wrong with there being calculations in Diamond, okay? It's not seen as useful for the rest of the organization, and it's fine for them to add these calculations. What you need to do is have a constant feedback loop of anything that's being built in Diamond and see if maybe it should be pushed back to gold. But other than that, let people build what they want to build. So we're doing data quality concerns for the calculations of those segmented data sets, okay? To make sure that we segmented them correctly, okay? So if you start looking at, you want to put your own linear regression models in this area as well for predictive, for anomaly prediction, because you're protecting yourself from the logic you used to build that diamond layer. Does that make sense? And with that, so halt pipelines, because you have an SLA in that layer, right? So you might be better off with yesterday's data than today's bad data, okay? So think about that. Timeliness, obviously, if you have that SLA, that's important. With that, I finished with 1 minute and 12 seconds left. So I think that's pretty good. Any questions? Go for it, man.
Oh, hold on 1 second.
Oh, sorry.
That's okay.
I would make a Donahue joke, but I don't know. I might not get anybody understand that. Go ahead.
So what you explain is basically how it should be in different layers, right?
That's explain the way I see it. Absolutely.
Yeah. No, I agree on that. And say, for example, we have done that.
Yep.
Now, the tools that you have developed, whether it can implement, if it can, how much automation you have achieved so far?
So, you're talking to somebody that built a data quality product, right? So what I can say is the automation, I don't want to minimize our product. I love our product, but it's not that complicated, honestly. we detect change data columns. I thought that was going to be hard. That was really simple. The granularity involved there. Building a linear regression model is pretty simple in almost any flavor of SQL. It's even easier with data frames. So I don't believe it's complicated, but I might not be the right person to ask because this is what I do for a living, right? So I don't think it's complicated. I think expectations are going to be the way that most of you do this in the future. Of course, come buy our product. It's great, but you're going to have everything you need in expectations. Go for it. I think this is going to have to be the last one.
If we are not using delta live tables, what is the way to basically measure the quality?
Are you just using Parquet or?
Yeah, delta tables, right?
I don't think, I honestly don't believe it's, that there's, I mean, you don't have ACID transactions. You can't merge for correct data, but there's lots of ways that people have been doing that in data lakes before Delta Lake. So I think just restating, right? So if you have an enrichment table that has all of your anomalies in it, you can minus that against a base table and build another table. Or you can join it and write another table. So you don't necessarily have to merge. You might have a bunch more tables in Silver than what's ideal, but just give them a great naming standard so that people know this is the data with data quality errors. These are the tables without data quality errors, and maybe it's interesting to actually look at both. I have to stop it there. I really appreciate you guys sticking till the end, and grab me in the hall if you got any other questions. Thanks.